Right. So just try and solve these questions the best you can. Okay, so start with these two questions. You can start sending me your answers in WhatsApp as we go along. Yeah, Dhruv, you will have to check your internet connection because the audio is correct from my side. Aditya Vikram, your answer is correct. Yashmit, your answer is also correct for the first part. First question, part A. Viraj, you are also correct. Good. So far, I've got correct answers. Very nice from all of you. Some people are still joining in, but start solving the questions as. Yeah, Kevin, your answer is also correct. Good. Archit, correct. Yes, Aditya, second part is also correct. Yes, Kevin, correct. Dhruv, correct. Yes, Rajshekar, I have seen your doubt a couple of times. I have answered on WhatsApp also. So today's revision class, I'm going to teach the concepts again. So try to catch it this time. Okay, I have taught it many times. So hopefully you will be able to catch it this iteration of it. Okay, there's nothing difficult about it. If you go through my lecture notes carefully, it's given in a lot of detail also how to find that angle and things. Okay, so try to pick it up today. Okay, that's the best I can do for you. Okay, Dhruv, that's correct. Okay, so I'm putting up the answer for the first part. I'll give you the solution also. Should be getting 50 for this, and for this, that resultant angle, suppose we call it alpha, you should be getting it 37 degrees. Okay. Okay, good. Good, Ranak. Yes, Kevin, your answer for the second question is correct. So I'll give you the hint for the second part, all of you. So draw the two vectors, A and B, in an XY plane. The moment you draw it, you'll understand how to calculate the angle. Yeah, Archit, I will answer each. I will give the answers for each of the questions. Don't worry. Okay, so meanwhile, for those of you who have completed the first two questions, I'll come back to the question, don't worry. I'm just putting up a couple of more questions. I'll explain. Sarvesh, I'll explain your. Yes, Dhruv, you got this one correct. Yes, Raj, I'll show the diagram. Yes. Okay, Viraj, I'm putting up the whiteboard again. It's got logged out. People, I'm just refreshing the whiteboard. It's got logged out. Don't worry. Yeah, I'll put up the second question. Also the first one. Don't worry. Okay, so students, here's another look at the questions again. Yeah, Tanish, I know the screen has been not visible till now, but it's back online now. Okay. So I will just quickly solve each of these questions for you. So in the first one, you have to just use parallelogram law or triangle law, whichever one. Okay. So the solution of the first one. This was given, and we wanted to find the magnitude. So the first method was the triangle law, or that is the same thing as parallelogram law method, because both of them have the same formula, and that formula is that, yes, I'll show the third question, man, just a moment. Okay, so mod of a plus b is just root of a square plus b square plus 2ab cos theta. So we substitute all this. Okay, so that's 100 plus 1800 plus 2 into 10 into 30 root 2 into cos 45, which is 1 by 2. But we'll substitute theta directly over here as 45 degrees. So that will simply give you so 50. That becomes my mod of it. And along with that, you also have the formula tan alpha is b sin theta upon e plus b cos theta. So in that you substitute these things. So you will get your tan alpha as p by 4, for which you know that alpha is 37 degrees. This is the b part, this is the e part. This is by the formula based method. Okay. Also, if you want to understand the diagram, how it will look. So if you're going by triangle law, the resultant or sum triangle, that will look like this. Roughly, something like this. This exterior angle is theta equal to 45 degrees. This is vector B, which has a magnitude of 30 root 2. So in this triangle now, this here will be the sum, which is the resultant which we are looking for. And this will be the angle alpha. So we have calculated the sum's magnitude and the angle by the formula. Alternatively, we could also draw the parallelogram of vector A and B. So that parallelogram will look like this. We first draw the vectors from the common origin. That's, if that is A, then B will look something like this. Remember, in the parallelogram law, we draw the vector from common origin, not from head to tail like this one. Okay. In the triangle law, we first draw the vector A, then from the head of vector A, we draw vector B. But in the parallelogram law, we draw both the vectors from the common origin. So the angle becomes this angle over here. This is 45 degrees. And this is your vector B, which is of magnitude 30. So then you complete this parallelogram by drawing the parallel sides. And then in this, you can see that the sum of the two vectors is nothing but this one. This diagonal, which we call the primary diagonal of the parallelogram, that is the sum. And this angle here, this angle, This is the angle. So again, we have calculated it by the same formula. So whether we use triangle law or we use parallelogram law, they are the same formula. In fact, we don't even need to draw the diagram. We just apply the formula and that is it. So that is the solution of the first question by using triangle law / parallelogram law. Both are one and the same thing because ultimately the formula is the same. It's just the way we draw the diagram and visualize the problem is slightly different, but otherwise it's just to illustrate to you that both the laws are actually one and the same thing. This triangle is contained within this parallelogram, like we've spoken many times. And the important thing is the application of the formula to find out the resultant's magnitude and the angle that it is. So hope this is clear to one and all. Just going through the messages once more. Now I will also do this from this question by the component method, but just hang on. So till then, those who have not worked out the second question yet, you can work it out. Okay. And I'll put up the answers of the second question so we can verify. The answer to this part, vector E will be 10 root 3 I cap plus 10 j cap. Vector B will be 15 by 2 I cap minus 15 by 2 I cap plus 15 root 3 by 2. What are vector? And that is why the second part's answer will become vector E plus B. This. It is 10 root 3 minus 15 by 2 I cap plus 10 root 15 plus 2. This will be this. Okay. Then the answer for the third part should come out to be 25 when you work it out. And the answer for the fourth part should come out to be magnitude of A plus B is actually equal to magnitude of A minus B. It's equal to 20. So I'll show you the full solution of this also, but this is going to be, oh, sorry, it is, it's correct. It's perfect. So I'm coming back to the first and second question also, but this is first for those of you who solved the third question. Okay, so hope you've got a good look at this and we'll be coming back to this question. Yes, I will be showing you the second question also. But before that, coming back to the first question, we can also solve the first question by the second method, which is the component algebra method. So back to question 1, but by method 2, which is the component algebra method. So in this method, what I'll do is wherever my vector is, I'll assume that that is my x-axis. So if I've drawn the vector E like this, and its magnitude is 10, I'll just assume that in my system of coordinates, this is the x-axis, and this is the y-axis. So the vector E in component form will simply become 10 I. But then in comparison, how the vector B will be looking, it will be making an angle of 45 degrees with respect to the vector E. That means 45 degrees with the x-axis. And its magnitude is 30 root 2. So mod B is 30 root 2. And the angle with respect to x-axis, because I've assumed my x-axis is direction, is 45. So x component is B cos theta, y component is B sin theta. So using that, I can see that I can express vector B as 30 I cap plus 30. Just substitute these. So from that now I can see that the vector E plus B is equal to 10 I cap plus 30 I cap plus 30 j cap. So this we know how to do very easily. So x components add and your y components add, and we are left with 40 I cap plus 30 j. So this becomes the resultant as a vector in the component form. Now we wanted to find the magnitude of A plus B. So this is a bit of an indirect method. So we want to find magnitude of this vector 40 I cap plus 30 j cap. So for that we know the formula that it is square root of 40 square plus 30 square. So that is 50. So that's the first part. Magnitude of A plus B. So that's the first part. And the second part, we wanted to find out the angle alpha, that is the angle of E plus B as a vector with respect to E. Now here we have understood that the vector A plus B is 30 I cap, 40 I cap plus 30 j cap. We already got that about. And we also understand that the vector E was just 10 I cap. So it was along x-axis. So if we want the angle between these two, that angle alpha is just the angle of the resultant with respect to the x-axis. This only, this resultant vector, all I have to do is find its angle with respect to the x-axis, because the resultant is lying somewhere like this. Okay. And with respect to the x-axis, if this angle is alpha, that is the same thing as with respect to E. What is the angle of the resultant? Because E is already lying along the axis. So that we know is tan alpha is the y component divided by the x component of the resultant. So that is 30 by 40 or 3 by 4. So alpha is 37. We could also have used the component method. Though in this case, it was quite a straightforward question. So best was the method 1, that you directly substitute in the formula. But you could have also used this alternate component argument. So I'm just minimizing this if you want a reference to this. Yes, Viraj, I'm coming to second and third question. Yes. After people have noted this down, I will take you to the answer of the second or third question. Yes, I understood that. You just want the question and the answer. Yeah, so for a moment, I'll just take you back to the question set. Then we'll come to question number 2, solution. So this is the second and third question. Those of you need a reference to it. So that's the second and third question, and here you have the answers for the third question also. Okay, people. So hope all of you followed the first question solution fully. Yes. Sarvesh, to answer your question, we have not touched the two vectors because that is the principle of drawing the. If you're going with the triangle law, this is the method of drawing the vectors. The addition by triangle law, you first draw the vector A and then at the tip of vector A, you draw the vector B, or at the head of it. Similarly, if you're drawing the parallelogram, you draw them both from this. Okay. But in component algebra, it is you don't have to place the two vectors together. You can, you may not. It doesn't matter. Here I could have drawn this diagram like this also. It wouldn't have mattered because मुझे सिर्फ इसमें एक काम करना है. I'm not doing any vector operation from the diagram. You understand my point? So how I draw the vectors is not important. As long as their orientation with respect to XY axis is fine. It's not important how I draw them, whether I draw them at the same place or at different places. तो मुझे क्या करना है? मुझे सिर्फ vectors को component form में लिखना था. I did not want to do the addition in the diagram. Okay, I just wanted to convert the vector A in component form and vector B in component form. So I could have drawn them like this: A over here and B somewhere over here. Or I could have drawn them like this: A over here and B somewhere over here. It doesn't matter. They're all the same. So my only job in this diagram was to convert these vectors. So whether I draw A over here or I draw A over here, as long as it's the same vector, it doesn't matter. And similarly, my only job with the vector B is to convert this arrow into components. So as long as this magnitude is 30√2 and this angle is 45, it's fine. Wherever I draw it, it's fine. Because the actual operation I'm not doing using the diagram. Actual operation I'm doing using this and this. So for this, it doesn't matter where A is. I'm just interested in B. And for this, it doesn't matter where B is. I'm just interested in A. That's why I draw them independently. Okay. Yes, Archit, to answer your question, I will be covering the hardest level of question also, which is going to come in today's test. Don't worry. I understand your anxiety for the test coming up, and little bit of nervous energy is very good because it will keep you alert for the test. It's a good thing that you're thinking anxiously about the hardest question and all that. But don't worry, as promised to you, I will cover all the level of questions which will be coming in the test. So anyway, so this was the first question's solution for you. Okay, now let me come back to the second question. Now the second question is the slightly tricky type of one. Okay, you are given these two vectors and you want to find the angle between them. Okay, now many of you might have studied ahead in vectors, or at some other point of time you might have studied something called product of two vectors, scalar product or dot product, and from that we can find the angle. But here I am not taught that yet, so I don't expect you to solve by this. I expect you to solve it by a very basic concept, which is this: that given the two vectors are two-dimensional, yes, that's mean Tanish, the answer is correct. 105 degrees I've given here also. So given the two vectors, all you have to do is draw them in the component, in the axis frame, in the xy frame, and then by geometry you can find what the angle is. Okay. So this is the method that I'm going to take, and this is the method that I expect you people to do for right now for this type of question. Okay. Later when we study dot product, you will see that there is another way of solving this question also. But right now, even if you know that method, you can stick to this method which I'm telling you, because there's a lot to learn from this also. So question 2, we are given the vector E, which was √3 I cap plus j cap, and we were given the vector B, which was minus 2 I cap plus 2 j cap, and we wanted to find the angle between them. Okay, so what I will do is, with respect to a standard coordinate frame, I will draw both these vectors first. And this time, because I'm comparing the two vectors, I will draw them from a common origin. Okay. So just a moment. I have people who are just. So with respect to my standard coordinate frame, if I look at vector E, how it's going to look like. So this is where your knowledge of component algebra becomes important. So vector E now will look something like this. You realize that vector E has an x component of plus 2, 3 and a y component of plus 1. So the vector E should look something like this. This is my vector E, where if I drop this perpendicular on the x-axis, I know that this should be root 3. And if I drop this perpendicular on the y-axis, I know that this should be 1. So if I want, I can calculate this angle. If I want, I can calculate this magnitude. So over there, you can see that tan alpha. Now, alpha is not some arbitrary angle. It is the angle that E is making with the x-axis. So tan alpha is equal to how much? Perpendicular upon base. So it is 1 by root. So it is basically equal to E is y component divided by E is x component. So that means alpha is equal to how much? 30 degrees. This is the first thing. And if I require, I can find A also, but I don't really need that. So I didn't find the magnitude. Now, similarly, let me draw the vector B in the same diagram. So many of you have been having difficulty with this type of question. Pay attention here. So vector A के अगर components दिए हुए हैं, whatever they are, positive, negative, it's very easy to draw them. So for example, vector A का यहाँ पे x component positive है और y component भी positive. So vector A is lying in the first quadrant, such that vector E is angle with the x-axis, which instead of theta, I've labeled it here as alpha. So that alpha is how it is such that tan alpha is y component divided by x component. Just apply trigonometry. So tan alpha is becoming how much? 1 by root 3. So that means alpha is 30. Okay. Now similarly, if you see vector B, it has a negative x component. So like this and a positive y component. So vector B is something like this. Okay. Now your diagram doesn't have to be exact. You can do a bit of trial and error and you just get it. But you see that this is minus 2, the x component, and the y component is positive. So let us say this angle is the angle that vector B is making with the x-axis. Okay. Or if you want, you can just simplify things for yourself and just take this angle as something else, like gamma or something. That will also work, no problem. But I am doing it by the more formal method. So for vector B, you can see Bx is negative, By is positive. So that is telling me that the angle beta is in second quadrant. I understand that. So it's in second quadrant, so I'll use the second quadrant formula. So now for this is for vector B. So tan of its angle, which normally I write as theta, but here I've written it as beta, is nothing but y component divided by x component. So this, as expected, is becoming a negative quantity. It is plus 2 divided by minus 2. So it's becoming minus 1. So as expected, second quadrant. So I have tan beta is equal to minus 1 and beta is in quadrant 2. So I'll use the formula for quadrant 2. So formula for quadrant 2 was what? Quadrant 2 formula was that tan theta is equal to minus of tan 180 minus. I'll use that. So minus of tan 180 degrees minus beta is equal to minus 1. Or next step, I can understand that tan 180 degrees minus beta is 1. Just cancel the minus sign on both sides. So 180 minus beta is how much? It is 45 degrees. Which means that the angle beta, as you can see in the diagram, it is a obtuse angle. And precisely its value is how much? 135 degrees. So we have got beta as 100. That's why I said that it's a little lengthy, because you have to work out the angle with the proper quadrant also. So let me just minimize this. So now you've understood that in this above diagram, I've already got the value of alpha. This was for vector E. I got the value of alpha as 30 degrees. And below here, I've got the value of beta as 100. Now let's come back to the diagram. Which angle I want to find out now? I want to find out the angle between A and B. ये दोनों vectors के बीच मुझे angle निकालना है. That is the angle between this one and this one. So this diagram, what is that angle I'm talking about? That angle I'm talking about is this. This is the angle between the two. This is the angle theta. So theta, the angle between A and B, is what I wanted to find. But you can see from the diagram that theta is actually nothing but beta minus alpha. Okay. So that's it. So now we'll substitute the values. Finally, that will tell us that is 105 degrees. That is the angle between. And see, here I've done it with a lot of complete steps and explaining everything in detail. But really, once you're used to vector algebra, it will not take you so much time, okay? Because you realize the moment you see -2 and +2, you know that it's in the second quadrant, such that this angle is 45, because these components have same magnitude 2 and 2. So ये वाला angle 45 है. So you know that this beta is 180 minus 45, it's 130. And this one is √3 and 1, so you know this angle is 60. So sorry, is 30. So now the difference of the two is 135 minus 30. So it's 105. So with a bit of practice, this thing will become more obvious. But yeah, even if it is not 100% obvious, you can always do all the steps very carefully, one by one, without being in any hurry and all that. You can just systematically do all the steps and come to the correct conclusion like I've done. Okay, now, as of now, because we haven't done scalar product yet, there is no second method for doing this question. This is precisely the only method as per what we have learned till date in vectors to find this angle. Yeah. Very soon we will learn another method also. But actually, this is as good as any method. Okay, so anyway, tan alpha is ay by x. That's why it's 1 by root. See, always when a vector is given, Sarvesh, to answer your question, when a vector is given like this vector is A, and over here with the x-axis, this angle is alpha. So when you drop this perpendicular, what is this height over here? It is nothing but the y component. And what is this base over here? It is nothing but the x component. That is the principle of vector. Because on the y-axis, whatever projection it throws, this projection, this is ay. That's the same as this side. And this projection is ax. So that is why your tan alpha is perpendicular upon base. So that becomes the y component divided by the x. Which question I have done this? No, this question also, see, it is done y by x, ry by rx. Everywhere tan alpha is, I mean, the angle with respect to the x-axis is always the same. It is the y component divided by the x component. It's okay. You get confused sometimes. Okay. Now, Raj, hope it is clear now. This was the type of question you were having some difficulty with, Raj. So I hope this is clear now. So it is like a little bit lengthy because it's a two-step process. पहले आपको एक वेक्टर का एंगल निकालना है, फिर दूसरे वेक्टर का एंगल निकालना है, and then दोनों को subtract करना है. Okay, so best way, Raj, is always to draw a diagram like this, in which you are able to place the two vectors and very easily see what the angle between them. Okay, so hope this is good, right? Thanks. So now let's come to the third question. So I'm just taking you back to the third question's language. So this. So what I'll also do is I'll just copy this question. Okay. Right. So all right. So in this question, first of all, let us express the vectors A and B. So A is pretty obvious. Magnitude of the vector A is 20, and the angle is 30 degrees. So A is becoming A cos 30, that is 20 cos 30, that is 10 root 3 I cap plus 10 G. Okay, because you know that sine 30 is half and cos 30 is root 3 by 2. So using this, okay. So A was fairly simple. The one which was a little bit complicated in comparison was B, because of the way B was drawn. Okay, so I'm just bringing your attention to the vector B. Okay, so this vector, as you can see, first of all, we have to gauge its direction correctly. Okay. So its direction is actually not fourth quadrant. Its direction is like this. It's pointing along this direction. See, it's pointing like this. The arrow's head is pointing like that. So it's actually in second quadrant. So let's draw the vector B again to get more clarity about it. So how to get maximum clarity about a vector's direction? Just redraw it from the origin. If some vector is given randomly somewhere in the xy space, then always pick up that vector, and in case we are a little bit confused about how that vector is pointing exactly, just pick that vector up and place it at the origin. Then things become very simple to understand. So if I do that over here, I just pick up this vector here and place it at the origin over here. So this vector looks like this. I'm making it slightly bigger, but basically it's the same as this. Okay. So it's of magnitude 15. This is the vector B. Now see, this angle was 30. So over here, this angle should be 30. So this angle here is 30 degrees. Okay. So you can see that what is the angle that actually the vector B is making with respect to the x-axis, with the positive x-axis. That angle is this. So that theta for the vector B, the magnitude is 15, but the angle theta is 90 plus 30 or 120 degrees. Okay. And again, you should know that sine 120 is the same thing as sine 60, which is the same thing as root 3 by 2. Whereas cos 120 is negative of cos 60. So it is minus half. So that is why now using sine theta and cos theta and the magnitude, you can see that the vector B component form में कितना हो जाएगा? It will become minus 15 by 2 I cap plus 15 root 3 by 2. So this is a very critical step over here. This is a very, very critical step. So I'm just minimizing this a little bit for you to. So this is how I figured out the vectors A and B. Alright, people. So hope this is correct and this is clear to all of you. Okay, now once you've done this, so this is the first part. We wanted to express A and B in component form. That's done. Now the second part, we want to find out E plus B as a vector in component form. So just add the two, just pick them up from there. So this was 10 to 3 I cap plus 10 j cap, and to that we are adding this vector below, which is minus 15 by 2 or minus 7.5 also you can write it as plus 15 root 3 by 2. So it is just algebra. Okay, just don't make sure that you don't make a mistake of sign and all that. So this is 10 root 3 minus 15 by 2 I cap plus 10 plus 15 root 3 by 2. And I mean, typically, we don't need to do anything else. You don't need to substitute root 3 as 1.73 and do a decimal calculation. You can just leave the vector this way. It is fine. If you want, we can do a little bit more of simplification. We can take things common a little bit. So we can also write this as, you take 5 common over here. It is, as you can see, you have 2 root 3 minus 3 by 2 here. And from here you have 2 plus 3 root 3 by 2. But nothing major. It's the same thing actually. I'm just doing this because sometimes cos 37 surface is that 37 degrees always, I told you to remember this triangle. 3, 4, 5 triangle. 3, 4, 5 triangle में ये जो छोटा वाला angle है वो हमेशा 37 है. Because the smaller angle will be opposite 3, the larger angle will be opposite this. Which should be 15 by 2. Archit, which question you are talking about? This one? Minus 15 by 2 and plus. So this is correct. Which one? This should be plus 15 by 2. No, it is minus because you can see it's in second quadrant. So the x component is negative and the y component is positive. And that angle theta is 90 plus 30. So that's why it's 120. So this is how it's working. So now take I cap common. So I cap common लेके क्या रहा है 10 root 3 minus 15 by 2. और j cap common लेके 10 and plus 15. And then from this whole bracket I've taken 5 common. So that's done. Now the third part, we want to find out magnitude of A plus B. So it is mod of this vector. So it is, no, actually that is the thing. It is in quadrant. It is not in quadrant 4. That's what I explained to you. See, actually, this is what I explained in this diagram. This vector, it's okay. We'll spend some time on this. It's important to understand. This vector, जो B वाला vector है, वो ऐसा point कर रहा है. Fourth quadrant में अगर vector होता है तो कैसा point करना चाहिए? It should have been pointing like this. If it go in fourth quadrant, then that same vector should have been pointing like this. This is a vector which is in fourth quadrant. Because this vector you can see is such that its angle with the positive x-axis is in fourth quadrant. Okay. But this vector is actually pointing in this direction. It's not pointing down here. It is pointing in this direction. So if we draw it properly, redraw it such that we draw it with respect to the origin, we'll have to pick it up and place it here, such that its origin is at the intersection point of the group. So you can see that this is in second quadrant. This is in fourth quadrant. Okay. So this vector here is this one. It is not this one. Yeah. So actually that is why we have to be very careful about the arrowheads diagrams. Okay. All right. Now comes this. So we have to find mod of this. So it is square root of 10 root 3 minus 15 by 2 whole square plus 10 plus 15 root 3 by 2. So let's just do this. So this will become 300, okay, plus 225 by 4, okay, minus 152. That's the first term, correct? A minus B whole square. And similarly, the second term will be 100 plus 675 by 4 plus the same thing, 150 root. Okay, so you can see this term and this term cancel out, and we are left with what? We are left with 300 plus 100, 400. Okay, and then 225 plus 675. So that's how much? 900 by 4. That's 1600 plus 900. So 2500 by 4. That is 50 by 2. Okay. So this is our mod of A plus B. So इसमें कुछ नहीं है. There is this algebra, nothing else. Okay. In fact, it's arithmetic, not algebra. That's another way of expressing the same vector branch. Okay, we can take something common and express. So this and this are same. This is the same as this. So I have shown you like this because you can always get a question in which the option is given like this. Okay, for example, if a vector E is, let us say, it is 4 I cap plus 2 j cap. Suppose you can always express that same vector as 2 times 2 I cap plus j cap, or we can express that vector also as 4 into I cap plus 1 by 2 j cap. These all three vectors are the same. They represent the same information. So because you have MCQ questions where you have to mark the correct option, so it can always happen that in a question the answer is this, but the answer is not given in this form. The answer is given in this form after taking the 5 common. So you should know how to convert this to this. So again, that is just arithmetic. Yeah, Harsh, the topics which are coming are addition, subtraction, component algebra of vectors, triangle law, parallelogram law, applications. What all we have done till last lecture, that only is coming. Harsh, sine and cosine laws are not part of vector algebra as such. They are trigonometry laws. For example, your cosine rule is the statement of the triangle law. Okay. So in that form it will not come. Similarly, what you know as the sine rule in trigonometry for any triangle, that is A upon sine A is equal to B upon sine B, that one, that has a corollary in vector algebra also, and that is called Lami's theorem. But we'll be doing that later. We haven't come to that yet. Okay. So there is an equivalent of the sine rule of trigonometry for vectors also. It applies to a triangle of 3 vectors. Okay. Yeah, Sami, I will explain the hexagon question again later today. Alright, so this is clear. Now the fourth question the fourth part you wanted to compare A plus B and A minus B. Okay, so you wanted to compare A plus B A minus B. So first let's just calculate A minus B. So A minus B here will just become the vector A which we had written 10 I cap, wasn't it? Okay. 10 I cap plus 10 root 3 j cap. Sorry, 10 root 3 I cap plus 10 j cap. My mistake. But this time we are doing minus of minus 15 by 2 I cap plus 15 root 3 by 2. So this time when we do it, we see we get 10 root 3 minus minus plus of 15 by 2 I cap plus 10 minus plus, so that's minus. It's just a very interesting thing that this vector has the exact same magnitude as the vector A plus B. When you work it out, you will see it will come out to be 25. So next step, the magnitude of A plus A minus B is square root of this component, that is 10 root 3 plus 15 by 2 ka whole square plus 10 minus 15 root 3 by 2 ka whole square. Very good, Archit. If you've done it by another method, then I'm happy, and I will ask you to share the method also. We'll discuss that very soon. So again, as you can see, this term and this term cancel out, and it's a very interesting thing that you get the exact same thing. You get this as 25. When you do the full working, you get this as 25. Okay. Now there is another way of doing this. We'll discuss that also. In fact, yes, very good, Devash. That is the point I wanted you to understand. That this method that we have used, it is literally like catching your nose from behind like this. This thing is like that. We could have done just this, very simple. Okay. And the trick to that lies in the diagram, and it lies in the theorems. Okay. So that is why, yes, I'm going to come back to the theorems and their importance. If we come by triangle law only, so Raj, just to answer your question, how mod A plus B is equal to mod A minus B, we've actually done a question based on this in worksheet 4 also last time. That what is the condition for the resultant's magnitude to be equal to the difference's magnitude? And we saw the condition for that is that cos theta should be 0 or theta should be 90 degrees. So this is like an application of the reverse of that statement. Yes, I'm coming to it, yes. I'm coming to the shortcut method only, don't worry. So see, earlier in the diagram, we did not take note of one very interesting fact, which actually should have struck us immediately when we did the question there, that the vectors A and B have a special relationship, that they are perpendicular to each other, because the vector A was like this. It made an angle of 30 degrees with respect to the x-axis, like this. And the vector B was pointing in this sort of direction, where this angle was 30. So when we drew it properly from the origin and all, we would have drawn it like this. So the vector B would have properly been drawn for something like this. So this was our vector B, such that this angle was 30. Remember that. Okay. And its magnitude was 15, whereas magnitude of A was 20. So now you can see something very interesting. If you think geometrically, the angle between A and B is 90 degrees. And this is something that we should have noticed then. Okay. So theta between A and B is equal to 90 degrees. Okay. Now, whenever we get this condition that two vectors are perpendicular to us, it should ring an alarm bell in our head. And that alarm bell is this, that mod A minus B is equal to mod of A plus B, which is equal to root of A square plus B square. So even the second part, for example, where we found out the magnitude of vector A, we did too much work actually. I mean A plus B, we did too much work. We should have just done this. So it is a hypotenuse of 20 and 15. So it is. It was not necessary to do that much work over there. Okay. So why this happens is, to understand this, that mod of A plus B is root of A square plus B square plus 2AB cos theta. And mod of A minus B is root of A square plus B square minus 2AB cos theta. And whenever, if theta is 90, cos theta you know is 0. So that's why this happens. That's why this happens. And in other words, if you see the parallelogram formed by A and B, this is the vector parallelogram. It's in fact a rectangle. So because this angle is 90 degrees, this is a rectangle. So rectangle has equal diagonals. No? So another way to understand it is that whenever two vectors are perpendicular to each other, okay, what happens is that the vector parallelogram of A and B is actually a rectangle. It's no longer a general type of parallelogram. It's a special case of, and rectangle has that property that diagonals are equal in length. Okay. So that is why one diagonal is mod A plus B and the other diagonal is mod A minus B. And the length of that diagonal is just the hypotenuse of a right angle triangle formed by A and B. So that is. So actually we should have been mindful of this when we made the diagram only. The moment we understood in the diagram how A and B are there, with a bit of practice, once your sight becomes very keen in these things, you would have noticed immediately in the diagram, okay, the angle is 90. So when you saw the third part, which is mod of A plus B, and then the fourth part where you have to compare mod of A plus B and A minus B, you realize that you didn't have to use the component method because that's too lengthy. You see that theta is 90 is a special case when the magnitude of the sum is equal to the magnitude of the difference, which is equal to root of A square plus B square. Yes, questions are of exam level only, don't worry. Questions are of exam level. I will also be giving you a revision worksheet this week, which will have MCQ questions of this type. so that right now we are discussing questions where I'm just asking you for the answer, but they will have to select the options. Yes, loading the screen. Okay. Yeah, to answer your question about pattern of exam and all, I'll tell you in the answer. Okay, I'll tell you in the each. I mean, the exam is a 3-hour exam with 3 sections: physics, chemistry, and maths. So each of the sections will have a total of 25 questions. Okay. So physics will have 25 questions, chemistry will have 25 questions, and maths will have 25 questions. And in the physics part, 13 of the 25 questions will either be vectors or kinematics, and 12 will therefore be either kinematics or vectors. Now that I cannot tell you just now that which one will be 13 and which one will be 12, but there will be roughly equal number of questions in kinematics and roughly equal number of questions in vectors. And also that the type of questions, there will be 2 sections in physics. Okay, one section will be only one option correct. Yeah, NEET pattern will be only MCQs. That is the only difference between NEET and IIT. Okay, in NEET options. Okay, so anyway, so 25 questions जो होंगे उसमें से 20 questions will be single option MCQs. Okay, so physics section will have section 1, which is 20 questions of single correct MCQ. So out of 4 options A, B, C, D, okay, in these 20 questions, one option will be correct A, B, C. And for the correct answer, you will get plus 3 marks. For the wrong answer, you will get -1. And if you leave the question, you will get 0. Okay. So if you mark the correct of A, B, C, D, you will get plus 3. If you mark the wrong one, yes. And there will be section 2, which will be 5 questions only. So total of 25 questions in physics. So 5 questions of what we call integer answer type. So in integer answer type, yeah, +4 only. Oh, sorry, I've written wrong. Is the standard JEE pattern +4 -1. Okay. And integer answer type question will have single digit answer. So you have to mark the option between 0 to 9, a single digit. And this will not have any negative marking. Okay. Yeah, I'll take you through an example of integer answer, don't worry. Now let's continue ahead with some more questions and we get the idea. Okay, just try this out, people. So it's given to you that the vector E and the magnitude of E plus B have the same magnitude of 5 units. Whereas the resultant of A plus B makes an angle of 120 degrees. No, so Dhruv, in the multiple choice questions, it is not multiple choice of more than one option correct. It is multiple choice of single option correct. Okay, so there are two types of choice questions. One where out of A, B, C, D, some combination is correct. Either A, B is correct or C, D, like I gave in the last worksheet. Okay, and the other is like I gave in the section 1 of last worksheet, which was out of 4 options A, B, C, D, only one is correct. So suppose B is the correct answer, then if you mark B, you will get +4. If you by mistake mark A or C or D, then you will get -1. And if you leave out the question, then you will be given neither positive nor negative marks. Okay? That is the minimum. No, Kevin, unfortunately, your answer is not correct in this case. See, A plus B is making angle 120 with respect to A. It is not the angle between A and B. Okay? And B's magnitude is not 5. So, Dhruv, I hope you understood. In the section 1 of your test, which is coming up, only single option will be correct. So, out of A, B, C, D, only one option will be correct. So, if you mark that option, then only you will get positive marks. If you mark any other option, you will get negative marks. And if you don't mark anything at all in that question, you will get 0 marks because you walked over. Okay. So again, hint to use, you can try this question by both methods, by geometry or by this thing, by component method also you can try out over here. Okay. It's equally easy, both the methods, and we'll get the answer from that. But the answer is not 5 for part A. Okay. Hint to you is that it will be larger than E. The magnitude of B will be more than 5. Okay, so let me help you out with the triangle or the parallelogram method. Yes, Shristi, you're correct. So we go by the geometrical method. So we'll look at mod of a plus b is equal to square root of a square plus b square plus 2ab cos theta. So here this is 5, a is 5. This is like equation 1, and tan alpha is b sin theta upon a plus b cos theta. So this becomes tan 120 degrees is b sin theta upon 5 plus b cos theta. Okay, so this is my, so tan 120 is how much? Minus tan 60. So minus root 3 is equal to b sin theta upon 5 plus b cos theta. So this becomes my second equation. But as you can see, this is already going very lengthy because you have two unknowns, theta and b, and you have two equations. But solving this is a pain. You have to square both sides, compare sin theta, cos theta. So I'm not going. So I'll come back to this. But easier than this is, or just draw the vector triangle for a plus b. So that might give us an easier clue of how to solve the question, especially because you can see two sides of the triangle are equal. So we can make use of isosceles triangle. So if this is our vector E, which is of magnitude 5, now generally when we add, our vector B would be somewhere over here, like this, so that the resultant of these two, A plus B, is something like this, and this angle is alpha. But now notice that this angle alpha is 120 degrees. So that means where is my resultant line? It's very curiously lying over here. This is where my resultant is. This vector triangle is such that this angle alpha only is, what is given to us is that alpha is 120 degrees. Okay. And the magnitude of the resultant is the magnitude of E, which is 5. So that means this angle here that the resultant is making, this is 120 degrees. And the resultant's value is also 5. So that means in this diagram, where does the vector B lie? Is the third side of the triangle, this side. But here it's like this. That's the only way this can fit this. So this is like this. So this one must be the vector B. Otherwise, he has a possibility. So this one magnitude we don't know. And this angle theta, we don't know. So now let us see how we can make use of the triangle principles that we know. So by triangle, if this side is equal to this side, then this angle, suppose this is some beta, that will be equal to this angle. Okay, and this sum should be equal to this. So you can see that beta is equal to 30 degrees because this is 120, and therefore theta is theta plus beta. So it's how much? I mean, it's beta plus 120 degrees. This one. So it is how much? 150 degrees. Now we know this. So just by using that trick, I've not used any formula, but I've just used the trick that, yes, so the angle theta is becoming 150 degrees. Okay. And once the angle theta is becoming 150, now I can apply the triangle law formula to this, okay, and I can find out how much the magnitude of B is. So now I can use either of these two formulae. Okay, so substitute this in formula 1, for example, which we had got over there, that mod of A plus B is equal to that square root, that whole formula. So when we substitute here, 5 was equal to square root of 25 plus B square plus ये कितना हो जाएगा 10B cos 150 degrees. So this becomes the easy equation to solve. Okay. So square both the sides. So 25 is equal to 25 plus B square plus 10B. Now cos 150 is how much? Cos 150, second quadrant, is minus cos 30. So it is minus root 3. Right? So minus root 3. Right? Okay. So further, this is telling me that B square minus 5 root 3B is equal to 0, or B into B minus 5 root 3 is 0. Now obviously B is 0 is not possible. This is not a possible root. So B is equal to 5 root 3. That is it. So final answer is magnitude of B is 5 root 3, and the angle theta between A and B is 150, and we still have to find A minus B. So this is how you can see geometry can always come in handy, provided we make use of what is, what is assisting us in the, what is assisting us in the question is, when you read the question first, you should have made note of the fact that, okay, these two are equal. So how can I make use of this? Make use of the fact that the A plus B triangle is isosceles. Okay. Then it helps. If I just directly substitute in the formula, it's solvable. We can still see how to solve equation 1 and 2, but it becomes very lengthy. So it is not advisable to do it by that method. It was not advisable to do by this method. So this is also the geometrical method only, but we continued that by actually drawing the vector triangle and making use of this property. No, Raj, we use units. ऐसा नहीं है. Vectors are physical quantities which have units only. But the thing is, all the three vectors, when we are adding vectors or subtracting vectors, all three quantities A, B, and A minus B or A plus B, whatever we are doing, all the three quantities have the same unit. So here we are not interested in the unit, we are just interested in the magnitude. So for example, in this question, A and B could be forces which are in newtons. So A plus B would also be a force in newtons. A and B could be displacements in kilometers, then A plus B is also a displacement in kilometers. It's just an assumption that they are having the same unit. Otherwise, the sum and difference doesn't make any sense. Okay. When we apply vectors in future chapters, like when we apply it in Newton's laws, we'll be dealing with forces. So there we'll see that the force vectors will have unit of newtons. When we apply it in kinematics, in 2-dimensional and 3-dimensional kinematics, we'll see that they are displacements, velocities, etc. So those vectors will have units of meters per second, meters, things like that. Okay. So this was the geometrical way of solving the question. Okay. Now, in case you're wondering what if you had drawn the parallelogram, how would that have looked? So that's also giving you the same result. There's no difference. If you drawn the parallelogram instead, it would have looked like this. The parallelogram for A and B. That parallelogram would have looked such that this is the vector A. Now the primary diagonal, which is the sum of the two, that should be at 120 degrees. Okay. So this is a little bit tricky in that sense. This is the vector A plus B. And this is at an angle of 120 degrees. And this is also magnitude 5. Whereas the vector A is this one, which is also magnitude 5. So now imagine a parallelogram which has this as the primary diagonal. It's a parallelogram like this. Parallelogram like this. These are the parallel sides. So the vector B will have to be somewhere here. This is the vector B. This is A and B drawn from the common origin. So you can see normally we draw a parallelogram like this, where this is the sum A plus B, and this angle is alpha. But here alpha only is 120. So it's got stretched like this. The parallelogram is now looking like this. So this side and this side are parallel. This side and this side are parallel. And this is the primary diagonal. So it is the resultant sum. But other than that, the formula you will use is the same. Once you got this, within this, whatever solving you do will be using the same method. So you'll be saying that, okay, these two sides are equal, this side and this side. So these two angles are equal. So like that. Okay, so people hope this is clear by geometrical method. Whether you draw the vector parallelogram or you draw the vector triangle, it's one and the same thing. Yes, Dhruv, tell me. Okay. Now let's also do this by component method. In the component method, what I will do is I'll assume that my vector E is along my x-axis. Or in other words, I will just choose my x-axis so that it is along vector E. So vector E SI. Is 5 units along the x-axis. Then in comparison, how is the vector A plus B? According to the information given in the question, it's at an angle of 120 degrees to A. So my resultant, which is A plus B, is of magnitude 5 and it's at an angle of 120. So now convert this information to components. So when we write this information in components, it becomes like this, that the vector E is 5 I cap. The vector B is 5 cos 120 I cap plus, sorry, not B, but A plus B. The resultant of this, the resultant vector, that is this one. So that is this sine 120 J cap. So that is how much? Cos 120 is minus half minus cos 60. And sine 120 is positive of sine 60. So root 3 by 2. So this becomes minus 5 by 2 I cap plus 5 root 3 by 2. So this becomes the vector B. Sorry, this becomes the vector A plus B. My mistake. So this is vector A plus B, and this is vector E. Now I want to do what? I want to find out the vector B. So just subtract the two equations. So equation 2 minus equation 1 is A plus B minus A on the left hand side. So that is nothing but vector B. On the right hand side, it is minus 5 by 2 I cap plus 5 root 3 by 2 j cap minus of the vector A, which was just 5 I cap. Okay, so now just do the algebra correctly. So you will get this as minus 5 by 2 minus 5. And 5 root 3 by 2 minus 0, just 5 root 3 by 2 j cap. So what is my vector B? It is minus of 15 by 2 I cap plus 5 root 3 by 2. This is my vector B. So now I wanted to find out magnitude of vector B. So it is just square root of x component squared. So the minus sign doesn't matter, as you know by now. So that is 225 by 4 plus 75 by 4. That is 5. When you work this out, this will come out to be 5. And theta, so that is the angle between A and B. I want to find that out. So A is a vector which is along the x-axis only. It's 5 I cap. And B is a vector which according to this is like this. The vector B is this one. So in comparison, you can see that the vector B has an x component which is negative, minus 15 by 2, and a y component which is positive. So you want to find out this angle. This is the angle between A and B. Okay. So that angle is such that tan theta is nothing but B's y component divided by B's x component. Theta is in quadrant 2. So that is nothing but B's y component was 5 root 3 by 2 and x component was minus 15 by 2. So you see this comes out to be minus 1 by root 3. So tan theta is minus 1 by root 3. Okay, that means tan of 180 minus theta is 1 by root 3. So 180 minus theta is 30. So theta is 1. Okay. So this is actually also an efficient way of doing the question. So in case the isosceles triangle trick does not strike you, then the better method for you is to come to the component method. So definitely the formula is avoidable. The first two equations that we written by formula method, that what's happening is in the component method, here the question is not giving us A and B with respect to some coordinate frame because no diagram is given. That means we are converting it to components and then again converting it to angle and magnitude. So that means components हमको ही decide करना है. We have to decide what is the coordinate axis and then we have to remove the coordinate axis from our diagrams or from our analysis because we are giving the answer only in terms of mod B and the angle. So in that respect, it's like, I'm making use of the component method to find mod b and to find the angle theta. So how I should select my x and y axis? I should select my x and y axis so that I have maximum convenience. Now, in that case, it will be more convenient for me if I select my x axis to be along the vector E. So E could be anywhere. It could be towards north, it could be towards southeast or whatever. But E का जो भी direction है, उसको मैंने अपना x axis ले लिया है. So in comparison to that, A plus B is at 120 degrees, and in comparison to that, A and A plus B are having same magnitude. So this is how I would write in my coordinate frame where I have selected the x-axis along the vector E. This is how I would express them in component form. No, Archit, this is the more tricky type of questions that I'm using. We use tan alpha because we wanted to find out the angle between A and B. The second part of the question, we wanted to find out the angle between A and B. So we use that. Yes, Yashmit, along with this, I will also be sending a revision worksheet for you, which will have this level of questions, but in MCQ form. Yes, sure, I'll do that. So these were the steps involved. Yeah, you can say this is one of the tricky level questions. Okay, people, my laptop is again got locked out from the internet, so the white screen will go away for you very soon. But in the meantime, what I'm doing is I'm giving you another question on another screen while I get it booted. Okay? Okay, so people, hopefully you are able to see this screen which I've sent you. So while I'm just getting my laptop booted again, just try this question. I'll take you back to the solution of the previous one also again. Dhruv, try again. One small mistake you made. So I'm just reading out the question in case there's a problem with the symbols that you're getting at your end. So vector A, I'm repeating, vector A is I cap plus J cap minus K cap. And the vector B, yes, Aditya, you got correct. Vector B is I cap minus J cap. Okay, vector B is I cap minus J cap. And the final one, vector C is 2J cap plus 2K cap. So I'm repeating, A is equal to I plus J minus K. B is I cap minus J cap. And the vector C is 2J cap plus 2K cap. So you have to find the vector A plus B plus C first in I cap J cap notation in component form, and then the magnitude. Yes, Archit, you are correct, and so are you. Just a moment. So Archit is correct. Dhruv, check your answer. Aditya, your answer was correct. Magnitude of E plus B plus C is correct. Ayush, correct. Dhruv, correct. Kevin, correct. Both the answers are correct, Kevin. Sanya, you're correct. Yojit, correct. But you have to give the I cap, J cap also. Yes, so that is the correct answer. 2 I cap plus 2 J cap plus K cap. And its magnitude will come out to be 3. So that, if you're getting that, that is the correct answer. Okay, people, so I'm just bringing you back to our original whiteboard in just a second. Yeah. So just if you wanted to go through the solution of the last question once more, and here it is. Component form, this is the solution. Meanwhile, you're doing the question I just gave, then I'll put it up in a moment. Correct, Matt, your answer is correct. Okay, so let me just rewind up that question also. So anyway, I'll try to remember what it was. So were these the values? Okay. Can somebody just tell me what they were? E was how much? I plus it. E was I plus J plus 2. And then B was wait. So C was J plus A. And B was I cap minus B. So these were the values. So A plus B plus C as a vector, you have to just sum up their x components, y components, and z components. So the sum of the x components you can see is 1 plus 1 plus 0. The sum of the y components is 1 minus 1 plus 2. And the sum of the z components is 1 plus 0. Something is wrong. I think there was a minus k cap here. So you would have got 2 I cap plus 2j cap minus. This would have been your a plus b plus c as a vector in component form. So now next we have to find its magnitude. Plus oh, I think I've got it. This is also wrong. So anyway, the answer is the same. This here is minus 1 plus 0 plus. So this come out here. And finally, your mod of a plus b plus c will just become square root of x component square plus y component square plus z component square. That is root of 9 mod. So this is okay. Right now, let's wind up with one final question. Okay. So just work this out. Yes, Aditya, correct. Case 1, the answer is correct. Yeah, Archit, that should be the last video. After you complete this question. Correct. So all of you got this mostly correct. So this is formula based. You substitute cos theta in this case as minus half, and in this case cos theta becomes plus half. In this case you get mod a plus b as 10 and mod a minus b as 10 root 3. In this case you get mod a plus b as 10 root 3 and mod a minus b as 10. But actually through this question I want to illustrate one important point to you which you can understand from parallelogram. If we draw two vectors A and B and using them we draw a parallelogram where the angle between them is obtuse, then we always get a parallelogram which looks like this. Where the primary diagonal is the shorter of the two and the secondary diagonal is the longer of the two. So you can see something important over here. If theta is obtuse, then cos theta is negative. So that means the magnitude of A plus B becomes actually less than the magnitude of E minus B. Like you have observed by applying the formula in this case. When theta is 120, you can see magnitude of A plus B is 10 and E minus B is 10. That one is long. Whereas whenever the angle between two vectors is acute, then your vector parallelogram looks like this. So it is the primary diagonal which is the longer one. So in this kind of situation, A plus B will have a larger magnitude and A minus B will have the shorter magnitude. So if theta is acute, cos theta is positive. So mod A plus B actually becomes larger than mod of A minus B. It's not only this, you also understand that in this case, mod of A plus B is greater than root of A square plus B square. And mod of A minus B is less than root of B square plus B square. Whereas in this case, cos theta is negative. So actually, mod of A plus B is the one which is less than the hypotenuse of a right angle triangle. And mod of A minus B is the one which becomes greater than the hypotenuse. So those inequality type of questions, this is the thing, this is one of the things that we mind. Yes, this is the answer to the second. So final question of the day today. This is a question based on inequality. Okay, but see, I have asked for mod of A minus B, not mod of A plus B. So first of all, you know that theta is between 0 degrees and less than 90 degrees. So that means cos theta is less than is greater than 0 but less than equal to 1. So that means mod of A minus B, which by formula is root of A square plus B square minus 2AB cos theta. Now in this formula, see, this is where you have to relate this inequality with this formula to understand. So mod of A plus B, rather mod of A minus B है, इसका maximum value कब होगा? When cos theta is minimum, और cos theta का minimum value क्या है? 0. So it is actually greater than 0. It can't be equal to 0 also, because it is less than 90. So that means this is less than root of A square plus B. Whereas when is this minimum? Well, this cos theta term is maximum, and cos theta's maximum is how much? 1, and it includes the value 1. So that is this is what shows us over here that in this case, because theta is between 0 and 90, that means over here our mod of A plus B, our mod of A minus B cannot be 20. It is less than equal to 20, and at the same time it cannot be less than the difference, which is 4. So this has to satisfy this condition. Our given question, the condition on A minus B has to satisfy this. So only option B is correct. Only option B is correct. All other options are fine. Yes. So this inequality type of thing you have to be a little careful about. Rest of the questions are pretty direct, and as I told you that you always have the option of doing the question either by component method or geometrical method, whichever seems correct at that point of time. Yeah, Achit, to answer your question, you can send me your doubts, etc. So I think somebody else also, if I'm not mistaken, Sanya had told me you have some doubts, Sanya, about the hexagon question. So just send me that doubt on WhatsApp and I will send you a solution. Okay? And also make sure you go through today's revision set very carefully after the lecture is over. And I'll also be giving you a worksheet for revision, which will have some questions like this, but in MCQ format and all. And I think you should be well prepared. If you just make a revision on the last 2 or 3 lectures, the earlier lectures you need not do, but the last 2 or 3 lectures from the time we started the triangle law and then through components and component in 3D and yeah, isosceles triangle question I did by both the methods I did. So we solved the isosceles triangle problem by both the component method as well as the geometrical method. Solved it this way also, or we did it by the component method also. No, that method is the formula method. That I said there's no need to solve. This is too lengthy. The formula method is this. Now, if you want to sit and solve this, you have these 2 equations. The first equation will give you that b square plus 10b cos theta is equal to 0. So that will tell you that b is equal to minus 10 cos theta, something like this. And then you substitute this in the second equation, which is this one. And then you square both sides and sine square and all that. Yeah, so that's what I'm saying. That is too tricky. So don't attempt it by that method. Do it by the triangle method or by the component method. That will be the easiest. Okay. It takes a little experience in your trigonometry actually. The problem is not with the physics. The problem is solving an equation trigonometrically which has sine theta and cos theta. Okay. So if you come across a problem where you're unable to solve trigonometric equation because the same equation has sine theta and cos theta, for the moment at physics level you need not worry about it. I don't know how far you've reached in trigonometry maths, so whether trigonometric equation solving you've reached up to that level, but eventually you'll be able to solve, so don't worry. But right now you just apply the other method and you'll be fine. Okay. So yeah, that's it for today's class, people, and hope you have understood these questions. If you're clear with these questions, their solutions and the general methods, then you don't have anything to worry about for the upcoming test. I will send you a list of questions from your workbook from your module, as well as I will send you an additional worksheet for some practice for the upcoming test, and you should not have any difficulty. Okay, that's it for today, guys.